In today's tutorial, we're going to be creating this particular Easter egg loop. It's going to be made such that it's versatile and can be used for various other animations as well. The parameters are also going to be customizable, so it's definitely worth watching so that you can learn how to use simple math to make versatile things just like this reusable for future animations as well. So without further ado, let's actually begin the tutorial. But before we actually get into the tutorial, I just wanted to know if all of you would be interested in watching a very high quality, sophisticated animated video for the next demystifying video where we demystify another specific node in Blender. Or would you want a video similar to this particular video over here at the same quality where I just screen record myself using the node in Blender and use Blender's annotation tools and the grease pencil to actually explain how it's working. A really high quality video would take me at least 10 days to post, or maybe even longer, whereas a video of this quality would probably take me 2 to 3 days. So let me know which type of video you're interested in and I'll make it accordingly. And until that one comes out, let's go ahead and begin today's tutorial. In our default scene, we're actually going to be using the default cube, but let's go ahead and hide it for now because we're going to use that for the geometry node object later on. The first thing is actually creating the eggs. So let's press Shift A and search for a UV sphere or an icosphere. Now once you add in the UV sphere, you could increase the number of segments and rings from here, or you can go to the modifiers and just add in a subdivision surface modifier to make it much smoother. Now you can choose the levels based on what your computer can handle and what would be required for your particular animation. But in my case, I think a view of 1 should be good enough. To make this look smoother, we're going to go to Object and go down here to Shade Smooth, or you can just right click and choose Shade Smooth from here as well. Then we're going to press Tab to go into our edit mode, and we essentially want to select just this top vertex. So let's go ahead and select it and then press 1 to go into our front view. Then we want to create proportional editing. So we're going to tap O, or we're going to press this button up here, and once it's selected, we can go ahead and press G followed by Z and just lift it up to approximately an egg shape. So we can change the actual influence by playing around with the scroll wheel and just make a shape that you think resembles an egg. I think I'll go with something like that. Then I'll press Tab to go back into object mode, and here we have our egg. If at any point of time you feel like it's getting a bit too sharp towards the edges, you can always increase the number of subdivisions to make it a little smoother. Now that we have our egg, we have to give it an Easter egg-like material. So let's go ahead and play with the materials for now. Let's bring this to the side and switch this from the 3D viewport to the shader editor. Then let's press N to remove the side panel and press this plus button to create a new material. Let's go to the material tab and just call this egg, and maybe we can say .001. Now I essentially want the egg to have some sort of bands of color to make it look like it was painted on. Now maybe for the first one, we'll just have a wave that goes up and down in a sharp triangular pattern. So we can do that by using a simple wave texture. So let's press Shift A, search for the wave texture, and plug the color into the base color so that we can actually see what we're doing. And to actually see the changes, you're going to have to come up here, scroll to the right, and just change your viewport shading all the way to render so that you can actually see the waves. The first thing that we see is clearly the waves are on the wrong axis. To fix that, we'll press Ctrl T to add in a texture coordinate and mapping node, and then we'll switch this from generated to object. The next thing that we have to do is change this to the correct axis by playing around with this. So let's change this from X to the Z, and now you should have waves that go around the object, which is exactly how we wanted it. But clearly this is way too small, so let's just reduce the scale so that we get larger bands, and maybe something like that should be good. Let's maybe make this 0.6, and that looks great. I want this to be much sharper, so let's press Shift A and search for a color ramp node and plug that in right over here. Then I can simply change this from linear to constant, and then I can drag this white handle in from this side so that we can get whatever colors we want. Now I want the white bands to be fairly large and the black bands to be fairly thin, but then I want to change the black bands from black to some other color. I'll make it all the way to the brightest white, and I'll change this to maybe a saturation of 1 and a hue of 0.5. Now the reason why I'm doing this is because I want this color to also be randomly changed based on the various eggs that we create. And for that, we're going to use a hue saturation value node. So let's take these, move this to the side, and press Shift A and search for a hue saturation value. Let's plug that in, and in fact, just to give it a little bit of a glow, we can increase the value from 1 to a value of 2, which makes it a lot brighter. Now you can see by playing around with this hue, we can get all different colors: yellows, greens, blues, pinks, reds, everything. And we're going to actually change this color using a random value, which we'll get from an attribute later on. But for now, let's leave it as this. This could be good enough for one type of egg, but I don't want anything to be this simple. I want it to go up and down. Now we can do that by actually playing around with the coordinates that are entering the wave texture. Right now the coordinates are rectangular coordinates that are going in a straight line. We can take the coordinate system and shift them to go up and down on the z-axis to give it a zigzag look. So for that, let's go ahead and mess around with just the z-axis of the texture coordinates. For that, we have to first search for a combined xyz, and that way we get access to just the z value. The next thing that we want is to have the z value go up and down. We can actually do that using a gradient texture. Let's press Shift A and search for a gradient texture, and then with the node wrangler enabled, you can press Ctrl Shift click to actually preview what the gradient looks like. Clearly the gradient is not the way we want it, as it's going from this side to that side. So again, let's use the same object coordinates so that it first shifts to the center, and then let's change this from linear to radial. By changing it to radial, you see you get a gradient that goes from 0 and turns all the way around to a value of 1 like that. But we can then go ahead and search for a math node and change this math node from add to ping pong to have it change its value to go bright, dark, bright, dark, bright, dark. So let's go ahead and just reduce the value till it becomes fairly looping. So I think a value of 0.02 might work, as we get a bunch of rays that go dark, light, dark, light, dark, light. So now just the z value of the object coordinates that are coming out from this mapping node is going to go higher wherever this is slightly whitish. But of course, we can't just plug this directly into the vector, because that's going to take in this as the vector and no longer the actual object coordinates of the wave texture. We simply want to add this value that we're getting from the output of this into the texture coordinates that we've created over here. So to add in these values, we can press Shift A and search for a vector math node and plug that in right over here. Now let's add in this value that we created over here and then preview what the final output looks like. So now you're able to see that yes, this is going up and down exactly as we wanted, but it's not going up and down enough. So to do that, all we need to do is duplicate this math node by pressing Shift D and changing this from ping pong to multiply, and then we can just multiply this by any value to get this to be however high or low we want. So I think this looks like a great Easter egg, but maybe it's a bit too many. So to reduce that, all you have to do is play around with this ping pong node over here. So maybe instead of 0.02, maybe we can have 0.025. So I think this looks great, and this could be our first type of egg. Another egg that I would want is to have this a lot smoother than these sharp edges. So let's go ahead and press Shift D to duplicate it and then press Y to move it on just the Y axis. Now this is our second egg and we want to change the material. So let's come here and just press this duplicate button so that we have the entire setup already the same, but now we can make changes to just this material without making changes to the first material. Now in order to get this as a smooth wave, instead of going for a ping pong, we can go for a sine node. So let's tap X to delete the ping pong and press Shift A and search for a sine, which is a math node set to a trigonometric value of sine. Now remember, the input of a sine has to go from 0 to 2 pi, with the output going from 0 to 1. So we first need to ensure that the input is actually getting that much of a range, because the gradient texture only goes from 0 to 1. So if we were to just plug this into the sine and then plug this into the multiply, you'll see we don't exactly get what we want, because the gradient texture is only giving a maximum output of 1, where it has to actually be 2 pi at least to get one full sine wave. We want it to be even more than that. So let's go ahead and just duplicate this multiply node, plug it in over here, and for the time being, let's just multiply this by a value of something like 5. Now the next thing that you see is that okay, this output is very weird, and that's because we're multiplying the output sign by 10 as well, which is clearly not what we want. We want it to just go up and down by a little bit. So let's reduce this multiply node down to something like 0.5 for now. Now let's go ahead and start increasing this multiply, and now you can see we're able to get the nice smooth waves. Let's continue reducing this multiply node by a little bit more, so maybe a value of 0.1 or maybe 0.15, and then just play around with this first multiply node till it matches up perfectly, and now we have some smooth waves that go around this egg. Similarly, you can feel free to add in as many variations of this as you want by just playing around with different values within this setup over here, but for this tutorial I'll just leave it at these two. If you want the blend file without having to set all of this up, you can actually buy this as a single project on Patreon, or you can join our Patreon monthly tiers where you'll get the animations, the blend files, and the wallpapers that are created for every single one of the tutorials that I create on YouTube. However, once you're done with that, we can go ahead and start off with the geometry node section. Before that, let's just select both of these, press M to create a new collection, and let's press new collection and call this eggs. Then we can press OK, and we can go ahead and hide this collection because we don't need it for now. Now let's go ahead and unhide the cube and change this from the shader editor to the geometry node editor. Then with the cube selected, let's press this plus button to create a new geometry node tree. And if you can't see the nodes, just press period on your numpad with your cursor in the geometry nodes window, and the nodes should get centralized. We don't need the group input for now, so let's press Ctrl right click with the node wrangler enabled to just remove that connection. But we'll keep the group input as we're going to use that later on to make this more versatile. For the time being, we're going to start off by creating a plane, which is a grid in the geometry nodes workspace. Let's go ahead and connect the mesh into the group output and change the size according to what you want. So maybe I want the x-axis to just have a value of 5 units and the y-axis can have a value of 10 units. Now I want to distribute a bunch of points onto this particular grid. So let's go ahead and press Shift A and search for a distribute points on faces node. Let's plug that in right over here, and I'll reduce the density to something like 5. Now I want to be able to move these points up and down randomly, and for that I'm going to use a set position node. Now this set position node has a vector input for the offset, but I want to move it only on the Z. So to get control of just the Z, I'm going to search for a combine XYZ, and I'm going to press Shift A and search for a random value node. Let's go ahead and plug this value into the Z and plug this into the offset. Now I can play around with the min and max to get this to go up and down according to what I want. However, I want to make this more customizable, and I'll actually do all of the customizations later on. For now, I'll just leave this at -5 and 5. Now I want all of these points to keep moving down, and as they hit the bottommost position, they have to shift right back up. So to do that, I'm going to use a simulation zone. Let's press Shift A and search for a simulation zone. If you don't know how the simulation zone works, you can check out various other tutorials of mine where we go into details of how the simulation zone works. However, in short, it's really simple. Whatever geometry goes in over here gets manipulated and goes back in the next frame as the input. So we're going to go ahead and just move this by 0.1 on the Z-axis every single frame. Again, we're going to customize this so that you can choose how many frames you want this to loop over and all of that later on. But for now, we're just going to search for a set position, plug that in right here, and change the Z value to a value of -0.1. So now when you play the play button, or when you play the animation, you should see that they all move down, because every single frame it's moving down by 0.1, and that becomes the new geometry. Then in the next frame, it calculates another movement of 0.1, and that becomes the new geometry again, which is why it just keeps moving down by 0.1 units. I want it such that every time it goes below the least value that we've put over here, which is -5, it should shift right back on top. So that's going to be very simple to do. Let's just search for another set position, and this time we're going to offset it by a value of 10 meters up, so that when it crosses -5, it gets shifted up to +5. Now we want to move only the ones that go below 0.5. So let's press Shift A and search for a position node, which will give us the position of every single one of the points. Now we want to compare the Z value. So let's search for a compare node as well as a separate XYZ node. This way we get the actual Z value of each of the points, and we want to compare if the Z value is less than, let's say, a value of -5. Now, if it's less than -5, then this set position will kick in and it'll go up by 10 units. Let's go back to frame 0 to reset the simulation, and when we play it, every time it crosses 0.5, it comes right back on top, which will create a perfectly seamless loop, which is exactly what I wanted to create. Now that we have that, let's go ahead and instance our eggs onto each of these points. So let's shift this group output to the side, press Shift A and search for an instance on points node. Let's plug that in over here, and for the instance, we're going to search for a collection info node, because remember, all of our eggs are within a collection. Let's choose separate children and reset children and choose the eggs collection over here. Similarly over here, we're going to choose pick instance so that only one of the 2 eggs actually come in for each point. Let's plug this instance into the instance, and now we have all the eggs over here. Now, of course, the scale is way too high, so let's press Shift A, search for a random value node, and simply change the seed value to something random, change the max value to maybe something like 0.2, and plug this value into the scale. Now, maybe this is a bit too small. Let's change this to 0.5, and I think that looks great. The min can also be increased to 0.1, and that should be good enough. Similarly, for the rotation, I wanted to have some random rotation, so let's duplicate this random value node, change this from float to vector because rotation is a vector, and let's have the min to a value of -pi on all of the axes, and the max value can be +pi on all of the axes, and then the value can go into the rotation. Now, I do want all of these to rotate about their individual y-axes, so let's press Shift A, search for a vector math node, plug that in right after this random value, and let's add in something to the y-axis every time. For that, we have to search for a combine XYZ node, and now we can actually play around with this y value to give it rotation on its individual y-axis. We want this to also be looping, so we'll do this with the customization portion of the video. Now that that's set, I think we can go ahead and start off with the customization. The first thing is I want to randomize all of the colors. So let's go ahead and press Shift A and search for a store named attribute node and plug that in after the instance on points. Now I want to store a value for every instance. So let's change this from point to instance, and we're going to change this name to egg hue. The value has to be a random value between 0 to 1. So let's search for a random value node. Again, you can change the seed to whatever you want, something random, and make sure that the min is 0, max is 1, plug this value into the value. Now we're going to use this egg hue in the actual material. So let's just use this drop down to go to egg 001, and let's switch this to the shader editor. Then again, press period to get all of the nodes, and in case that isn't working, just tap A followed by period to centralize all of the nodes. Now we want to use this hue value to change the color, and we want to do it individually based on the random value that we just created. So let's search for an attribute node by pressing Shift A, searching for attribute, and then for the name, let's type in egg hue. Now remember, the type is not geometry, but it's actually for every instance, so we have to change this to instancer. And remember, we stored the factor, and so we can just plug this factor into the hue, and you should get a random hue for every single one of the eggs. And that's how we can randomize the colors with very minimal effort. So let's do the same thing for egg 002. So let's just choose the texture in the dropdown, press Shift A, search for an attribute node, change this type from geometry to instancer, change the name to egg hue, and plug the factor into the hue of the hue saturation value node. Now that's awesome. Let's go ahead and start customizing the rest of it. So let's go back to the geometry node editor, and the first thing that I want is to be able to control the actual density from the outside. So let's take this density, plug that in right over here. Similarly, you could change this X and Y size, but I don't think I want to have too much control over that from the outside, so I'll just leave it as is. The next thing is the seed of the distribute points on faces node, because that is actually going to randomize this quite a bit, and with this change in seed, we'll have changes in everything else, so we don't need to control any other seed. The next thing is how much we actually wanted this to shift up and down, which is the Z spread. So I want just one control, and it should move half of that in the top direction, half of that in the bottom direction. So let's take this and let's just plug this into the min for now. Let's tap N to open the side panel and change this name from min to Z spread. Now essentially I want half of this Z spread to go to the min and half of it to go to the max. So let's press Shift A, search for a math node, plug that in right over here, and change this from add to multiply, and let's multiply it by a value of 0.5. Now the min has to be negative, so let's press Shift A and search for a math node again, or let's just duplicate this multiply node and then change this from a value of 0.5 to a value of -1, which will make it negative. Similarly, this multiply doesn't have to be a multiply, it could also be divide, and we could just divide it by a value of 2 as well. That gives the same result. Then we can take this output and plug that into the max right over here. So now that we have the min and max plugged in, we can just go back to 0 and make sure that we're getting the appropriate animation. Now you can see the Z spread is not exactly as we wanted, so we have to go to our modifier properties and change the Z spread to be a value of 10, which will give us -5 on the plus axis and -5 on the negative, which gives us exactly what we started off with. Similarly, we can change the seed as well, just to make sure that everything's working. Let's change the seed and go back to 0, and you now have a new seed that's also working. Now the next thing is how many frames should it take for this to loop? Let's say I want to loop it every 300 frames. I'm going to go ahead and create a new input. For that, I'll press Shift A, search for a math node, and just take another input and plug that into the add node. Let's tap N and change this value to loop frames so that we know that it's the value after which the entire animation should loop. Let's change this to 300 over here. And how are we actually going to calculate it? Remember, this set position has to move such that every 300 frames we move by the total distance that this object was spread over. So we're actually spreading it over the Z spread distance. Now every 300 frames, something that's at the absolute top has to reach the absolute bottom, or every loop frame number of frames. So how do we do that? We have to divide the Z spread by the number of loop frames so that we get, and let's actually type this out so that it's easier for all of you to understand. We need it to move by Z spread amount, correct? If we divide the Z spread by the loop frames, you'll see that whenever we multiply this by the total number of frames, whenever the frames becomes equal to the loop frames, so let's say 300, every time we reach the 300th frame, it'll get cancelled out and we'll be left with just the Z spread, which is exactly what we want. Hopefully that made sense. So let's go ahead and divide the Z spread by the loop frames. So Z spread goes into the top socket, and we have to change this to divide, and we divide it by the loop frames. Now this value should go into the Z of the offset, but remember, we need to move it down, so it has to be negative. So let's multiply it by -1. Let's press Shift D, change it to multiply by a value of -1. You could also divide it by -1, it'll be the exact same, but by convention, let's multiply it by -1 and plug this into the Z socket. So we need to combine XYZ. Let's just duplicate this node over here, plug this into the Z, and plug this into the offset over here. Now if we were to go back to frame 0 and play the animation, it should work just fine, and it should loop at the 300th frame. Let's change this to 300, and then if we were to let the animation play through 300 frames, it'll perfectly loop. The next thing is the rotation about the y-axis, which we were adding in over here. This rotation has to go from 0 to 2 pi every time we reach the loop frames number. So we have the loop frames right over here. Let's press Shift A and search for a group input so that we can just take the loop frames from here again without having to draw in another line all the way from here. And then let's press Shift A and search for a map range node so that we can go from a value of 0 to the loop frames value and change this to a value of 0 to 2 star pi, which is one full rotation. So now every time this is going from 0 to loop frames, we're going to go from 0 to 2 pi. But what is going? The actual frame. So we need the frame number. We can get that using a scene time node, and we can just take the frame and plug that into the value. Then we can take this result, plug that into the Y socket, and now it's going to rotate about the individual Y axes as well, and it's going to loop after we finish every 300 frames. So that's actually all there is to getting this to work. The last thing that you need to take care of to make all of this more versatile is playing around with this actual less than node as well as this set position, because remember, we just arbitrarily assumed that it's going to be 10 meters in length, but we're actually allowing that to be an input as the z spread. So this -5 over here is the bottommost point that any of these particles is going to reach, and we know that that bottommost point is going to be half of the z spread in the negative direction. So the z spread is coming out over here, we're dividing it by 2 to get half of the value, and we're multiplying it by -1 over here. So this is the actual value that has to go into the B socket of this less than node. So let's take this and plug that in right over there. Similarly, in this set position, we have to take this Z value only. So we have to press Shift A and search for a combine XYZ node. And from that combine XYZ node, we have to be able to use just the Z socket. So let's plug this vector into the offset. And for this Z value, remember it has to be the entire Z spread. So let's just take the Z spread from here and plug that in right to the Z value of the combine XYZ. So once you do that, you should be able to change the Z spread as well. So let's maybe change this to 20. And now if we were to go all the way back to frame 0 to reset the simulation, we should be able to have the simulation and still have it completely looping. You could do a lot of things like playing around with the lighting as well as the background. So I might, make the background a lot brighter so that all of the eggs are a lot brighter. But I actually want to change the color of the background that's perceived by the camera. And for that, we're going to go to the shader editor and change this from object to world. Then we're going to use a method that we've used multiple times before. We're going to search for a mixed shader node, plug that in right here, duplicate this background node, plug that in over here. And for the factor, we're going to search for a light path node and choose the is camera ray. So if it is a camera ray, it's going to actually use this second node, and we can change that to whatever color we want. So that becomes the background color, and we have the eggs just above. To place the camera, you can select the camera, press Alt G to clear location, Alt R to clear rotation, followed by RX90 to rotate it on the x-axis by 90 degrees. Then you can press 0 to go into the camera view, and you can press GY, just move it back until you get the position that you like. In my case, I think I want the x-axis to be the front, so I'm going to change the pivot point to the 3D cursor, which is present at my origin. Then I'll just press RZ, and I'll rotate my camera to rotate into the front view like this. So that looks good. And once I'm happy with the way everything looks, I can just go ahead and press render animation. Remember, your output settings are up to you. I'm actually going to change the output settings to be 200% so that it's a 4K animation. Frame rate is going to be 60 frames per second. Output folder can be wherever you want it to be. Double slash will save it in the same folder that you saved it. File format, I'm going to choose FFmpeg video with encoding container changed to MPEG-4 and an output quality of perceptually lossless. I will also definitely be playing around with the actual color management, because I think for non-photorealistic renders like this, standard looks a lot brighter, and you can always have high contrast and things like that. You can choose to play around with the exposure and the gamma as well to get the result exactly the way you want it to be. Once you're happy with the way everything looks, including maybe the focal length of the camera and things like that, you can go ahead and render out the animation. Thank you so much for watching, and if you actually made it this far, congratulations, because the audience retention for my videos is generally less than 2 minutes. I really do want that to change, which is why I do plan on creating one extremely high quality, well animated video. I don't know how much time it would take, and since I haven't been posting for almost a month anyway, I think it's about time that I take the risk to put in the effort and release one really high quality video. But do let me know if you think it's worth the risk, or whether I should just keep posting videos like this every alternate day or every day if possible. I really look forward to listening to what you have to say, and until then, thank you so much for watching. Keep creating, and don't forget to stay creative.